Hi, we're to approach to find the speed of the ISS. So step one, we're going to process the matrix data and generate a sine wave. We have to convert the matrix data into a wave. So the time it takes for the ISS to complete one orbit around the Earth can be determined. This is the graph showing magnetometer over time. Step two, we have to generate a sine wave from the processed matrix wave to provide a clean and predictable reference for easier calculation of the time difference.
So this is the graph fitting a sine wave with mag-x, and also there are two peaks and a first point of the 10-minute data we can get from ISS, and also its matching point. So what can we do to find these out? First of all, we need to analyze the wave and calculate the time difference. As known, we can find the whole wave by using 10 minutes, and then we will identify the peak and the starting point of a part of the wave cycle within the 10-minute data, and then we will find the distance between the distance of the first point and its corresponding peak, and with that we can find the match point because it has the similar distance. And then we can calculate the time difference between the corresponding points. Then, to calculate the total acceleration, which is about the distance, we will multiply Vx, Vy, and Vz of the accelerometer.
Okay. Now to compute total acceleration using this formula, which you can see on the PPT, then we can calculate the altitude from the velocity using the trapezoidal rule, which is also shown. And then step 6, we will determine the orbital distance and speed. First, orbital distance can be calculated from the altitude with the following formula. And secondly, the orbital distance and the time are both calculated, so now the speed can be found by distance over time equals to speed. So as a summary, our result is corrected to the two decimal place. The distance is 37,420.09 kilometers, and time is 5,640 seconds, which means the speed is 6.63. This is the end of this. Thank you for listening.